All right, let's jump right in. Today, we're going to go on a little journey. We're going to follow a single piece of code from a developer's laptop all the way into production, running as a live, scalable application in the cloud. And we're going to do it all using the awesome toolset that AWS gives us for DevOps.
This is really the fundamental question, isn't it? In today's world, speed is the name of the game. For any company that wants to innovate, the real challenge is closing that gap. The gap between a fantastic idea and actually getting it into the hands of your users. It needs to be short, it needs to be reliable, and that's exactly the problem we're here to talk about.
And the answer, of course, is DevOps. But what I find really fascinating about this definition is the order of the words. Notice how tools comes last? That's so important. Before you even touch the technology, DevOps is a fundamental shift in culture and in practice. It's all about breaking down those walls between teams to create one smooth, streamlined path to production.
To see what that culture looks like in the real world, just look at Amazon's famous two-pizza team rule. The idea is so simple but so powerful. If you can't feed your team with 2 pizzas, your team is too big. This simple rule encourages tight communication, real collaboration, and that feeling of shared ownership, which, you guessed it, are all core pillars of a great DevOps culture.
Okay, so with that philosophy in our back pocket, let's start our code's journey. First things first, we have to lay the groundwork. You can't build a massive skyscraper on a shaky foundation, and it's the exact same thing with software. We have to set up our core services in the cloud before we can do anything else.
And this is what we're aiming for. This diagram shows our end goal perfectly. We're not just trying to get an app running. We're building a complete architecture that is designed to scale up, stay secure, and handle failures without breaking a sweat. So keep this picture in your mind, because we're about to build this whole thing piece by piece.
So the very first piece of our foundation is compute power. In AWS, that's EC2. The easiest way to think of EC2 instances are as your virtual servers up in the cloud. This is the fundamental workspace where your application code is actually going to run, where your APIs will serve traffic, and where all the automated agents that build and test your code are going to live. Next up, every single application needs to store stuff, right? Well, S3 is pretty much the universal answer for that in AWS. After your code gets compiled, those resulting files, we call them build artifacts, they get stored here. All your application logs, your database backups, any files your users upload, pretty much everything just lands in S3. It's designed to be incredibly durable and basically infinitely scalable.
Now, we obviously can't just throw our servers and our storage buckets out onto the public internet for anyone to access. That would be like building a house without any walls or a front door. A VPC, that's your walls. It lets you carve out your own private, totally isolated section of the AWS cloud. It's your personal virtual network where you control all the rules, the firewalls, and who gets in or out.
And to manage who gets to do what inside that private network, we have IAM. The key concept here, and it's a huge one, is the principle of least privilege. All that means is you give every single user and every single service only the exact permissions they need to do their job, and absolutely nothing more. It's the bedrock of good security in the cloud. Now, this all ties into a concept that you absolutely have to understand, the shared responsibility model. Think of it like this. AWS takes care of the security of the cloud. That means the physical buildings, the servers, the global network. But it's on you to handle security in the cloud. That's your data, your firewall rules, your IAM permissions. AWS gives you all the locks, but you're the one who has to actually turn the keys.
Okay, our foundation is solid. We've got a secure, private place for everything to run and be stored. So, now for the really fun part. Let's build the automated assembly line that's going to take our code and get it onto that foundation. This is the heart and soul of what we call CI/CD, continuous integration and continuous delivery. This whole assembly line, or pipeline really, has 3 main stages. First, we have continuous integration, or CI. That covers the source and build steps. Every single time a developer pushes new code, it's automatically built and a whole suite of tests are run to make sure nothing broke. Then we have continuous delivery, which is the deploy stage. This is where that fully tested code is automatically packaged up and made ready to be released to our servers.
So the big question is, how do you string all those stages together so they just work? Well, that's where AWS Code Pipeline comes into play. It's the conductor of our entire orchestra. It's the brains of the whole operation. It literally watches your source code repository, and the moment it sees a change, Code Pipeline automatically kicks everything off. It triggers the build,
runs the tests, and starts the deployment, all without a single human having to click a button. It's magic.
So our pipeline is built, it's automated, it's fast. But speed without safety is really just a faster way to break things. Pushing new code out to a live application is always a little risky. So how can we deploy with confidence? Well, that's what this next part is all about, using smart automation and battle-tested strategies to minimize that risk.
Let's first talk about the servers themselves. Think about it. If you set up every server by hand, clicking through a console, you're just inviting human error. Maybe one server has a slightly different software version than another. That can lead to these nightmare bugs that are almost impossible to track down. This is where a truly core DevOps principle changes everything.
And that principle is infrastructure as code. This is a genuinely revolutionary idea. Instead of a sysadmin logging in and manually configuring a server, you define your entire infrastructure, your servers, your databases, your networks, all of it, in a simple text file. You treat that file just like your application code. You check it into version control, you review changes. It completely eliminates guesswork and makes your environments 100% reproducible.
The go-to tool for this in AWS is CloudFormation. You just write a template file that describes every single resource you need. Then you tell CloudFormation to build it, and it goes and creates everything for you in a perfectly predictable, repeatable way. The best part? If you need another identical environment for testing or staging, you just run the same template again. It's incredibly powerful.
Okay, now for the deployment itself. Two super popular strategies help us do this safely. First, there's blue/green. You build out an entirely new, identical environment, the green one, right alongside your live blue one. Once it's tested and ready, you just flip a switch, and all the traffic instantly moves over. Then there's Canary, where you release the new version to a tiny slice of your users, maybe just 1%. You watch it closely for errors, and if everything looks good, you gradually roll it out to everybody else. So let's recap. Our code has been built, it's been tested, and it's been safely deployed onto infrastructure that was spun up automatically. But we are not done. The journey isn't over once the code is live. Now we have to watch it, we have to listen to it, and we have to make sure it's happy and healthy. It's time to close the feedback loop with monitoring.
Your central hub for all things monitoring in AWS is Amazon CloudWatch. It's the service that collects pretty much everything. Performance metrics like how busy your CPUs are, all of your application logs, system events, you name it. And what's really crucial is that you can set alarms on all this data. You can set an alarm that says, hey, if the CPU on my server stays above 80% for 5 minutes, send a page to the on-call engineer. It's your eyes and ears on the system, 24/7.
But what happens when you have a really tricky problem? Especially in modern apps built with microservices, where a single click from a user might trigger a chain reaction across a dozen different services. Sometimes just looking at logs isn't enough to see the whole picture. That's when you need a specialized tool like AWS X-Ray.
Honestly, X-Ray gives you debugging superpowers. It traces a single request as it hops between all the different services in your system. It builds this amazing service map so you can visually see how everything is connected and where the bottlenecks are. You can instantly spot which service is throwing an error or where a mysterious delay is coming from. It helps you find the needle in the haystack in seconds.
And that really brings our entire journey full circle. This quote just nails it, doesn't it? It's not about mastering one single service. It's about embracing this entire philosophy. You define your infrastructure as code, you build a reliable, automated pipeline to get your code out the door, and you never, ever stop monitoring what happens next.
And that's it. That's the complete journey of a piece of code, from a developer's idea all the way to a resilient, scalable, and fully monitored application running in the cloud. I really hope this explainer helped connect the dots for you on how these amazing AWS services all work together. If you found it helpful, we'd love it if you'd like, share, and subscribe for even more deep dives into the technology that powers our world. Thanks so much for watching.